Welcome back. In this session, we'll learn the concept of circular convolution. So, circular convolution. What's circular convolution we shall learn in this session? Alright. Now, the circular convolution between two sequences. Let's suppose x1 of n, which is an n-point sequence. Let's call it x1 of 0, x1 of 1, x1 of 2, x1 of 3 and so on, x1 of minus 1. So this is one point sequence, and x2 of m, which is again an n point sequence, x1 of x2 of 0, x2 of 1, x2 of 2, x2 of 3 and so on up to x2 of m minus 1. So these are two n point sequences. So the circular convolution between these two sequences, let's call that y of n, which is the circular convolution between x1 of n and x2 of n, and the symbol used for this is like this. So this means n point circular convolution between x1 of n and x2 of n. This is the symbol used. This is the symbol used for circular. Alright. Now, what is the definition that we'll learn next? But remember, if x1 of n is an n-point sequence and x2 of n is a sequence which has less than n points. Now, how will you compute the circular convolution in that case? Then you have to add zeros to the second sequence, which has less number of points to make it equal to n point. Now, what I am saying, I mean this. Suppose x1 of n is this. Let me take an example. So this is a 4-point sequence. x2 of n is, let's suppose 1 minus 1 and 2. So this is a 3-point sequence. Now to compute the 4-point sequence, this circular convolution between x2 of n and x1 of n, what we have to do, so this means 4-point circular convolution. But what you have to do, you have to first make x2 of n equal to 4-point sequence. And how do we do that? We append zeros. So simply what we do, we append zeros to the sequence which has less number of points. Now same way, if we want to compute the 8-point circular convolution between these two sequences, so how do we do that? Now first what you have to do, you have to make these sequence equal to 8 points, meaning the duration should be 8. 2, 2 and 1, then we will add 4 zeros. This will make this sequence an 8-point sequence. Same way, we have to add 5 zeros to the second sequence. 1, it's minus 1, minus 1, 2, 0, and then we can perform the 8-point circular convolution between these two sequences. So here we have appended 5 zeros, here we have appended 4 zeros. So remember, in circular convolution, the sequences must be of equal duration. All right. And how do we make this sequences of equal duration? If we are not, we append zeros to the shortcut. All right. Now the definition of the circular convolution is, so the circular convolution between x1 of n and x2 of n, n-point circular convolution is given by like this: summation k running from 0 to n minus 1 x1 of n minus k and x2 of k. Now what is this? This is the circular shift of x1 of n. So the central to the circular convolution is circular shift. That's why we learned circular shift in the earlier class. And we can also write it like this. We can give the circular shift to second sequence. We can also write it as x1 of k, x2 of n minus k, and this means again the circular shift to the sequence. So we can either use this one or this one to evaluate the circular shift between the two sequences. Alright, so this is how we obtain the circular convolution between sequences. Alright, now to compute any value of y, means nth value of y, what we do, we need to use this summation, means we need to evaluate this summation here. And in this summation, we have one circular shift operation. We have one circular shift operation. So let's learn it. Let's learn this summation first. What are the terms that are involved in this summation? All this we can add up. Let me stick to the first form. Right? So this is the definition of circular convolution. Please remember this. This is the definition of actually the circular convolution. This is the circular convolution between two sequences. Right? Either you use this one or this one. These are one and the same. All right. Now let's learn this. What do you mean by what are the terms? So suppose I want to get the n equal to 0 point of this y sequence, which is the circular convolution between x1 of n and x2 of n. So the circular convolution, let me stick to the first one. So it will be k running from 0 to n minus 1, x1 of n minus, n 0. So it will be 0 minus k. 0 minus k n x2 of k. Alright, so this one gets sum. Now x2 of k is same as x1 of n. Sorry, x2 of n is same as x2 of k. So it is the same sequence. But what is this? What is this sequence? Minus k n. What is this? This is same as x2 of n. So what we have done is we changed the independent variable, means n to k. Otherwise, rest remaining the same. But what is this signal? What is this sequence? Now this means reflection of the original sequence. Now let's not confuse this with the origin, that the reflection operation that we learned in the chapter 1, and there is one circular, there is one this n here, and it means modular operation. If you remember the previous class, this means the modular operation. Now how do you obtain x of minus kn from x1 of k? So how do you obtain that? How do you? Now circularly you can get it very easily. You can get it in 1 second. Now let me show you first of that how you can do it very easily. So this I will arrange the these values of x1 of k over the circle. So suppose I arrange the points like this. So this is x1 of 1. Now I'm arranging these in the counterclockwise fashion. So this is x1 of 3, then so on. This is x1 of n. So this is our x1 of k, or simply x1 of n also. So I arranged the terms in the counterclockwise fashion. Now, how do I read this? How do I read from this? You can read it like in the clockwise fashion. So if I start from this, then you can say x1 of minus kn will be simply equal. You can read it like this. Start from the starting point a, that is a0. Then this first point will be x of n minus 1, x of 1, n minus 2 will be the second term. Then the third term will be n minus 3, and so on. Then it will reach to this x1 of 3, where reading the term is now in clockwise fashion. x1 of 2, x1 of 3. So this will be the last term. So last term will be this. So this is how we obtain x of minus k modulo n. This is how we read this one, right? Alright, I hope you understand how to. So first I arranged the terms in the clockwise fashion, counterclockwise fashion, then I read the terms starting from the origin point, means a point, then I read the term in the counterclockwise fashion. This is how we obtain x of minus k from this, right? So this is directly, without using this. Now let me give you the idea, what do we mean by modular operation today? What do we mean by modular operation? Now, I can also write this term like this. So let me expand this term, y of 0. How do I obtain y of 0? So y of 0 is summation k running from 0 to n minus 1, x1 of minus k n and x2 of k, right? So what you have to do actually, you have to multiply this with this term corresponding. So the corresponding value is x2 of 0, x2 of 1, x2 of n minus, sorry, not n, sorry, this is wrong. This is x2 of 2, so on up to x. Last term will be x2 of n minus 1. So this is our last term. Right? So what you are doing, let me first rub this, then I will tell you the what you are doing. See, you have obtained this term is now this term. So this is the term. So what you have to do in this summation, you have to multiply these two. So multiply the corresponding sample points. So if you multiply x1 of minus k and x2 of k, you will get multiply the corresponding term. So multiply this with this, and this with this, and this with this, and so on. Finally, you will multiply this with. So if you multiply the corresponding points, you will have x1 of 0, x2 of 0, and then x1 of n minus 1, x2 of 1, then x1 of n minus 2, x2 of 2, and then so on, x1 of 1, and x2 of n. Have a look, we are multiplying the corresponding terms here. So what then this summation tells you add the terms, add these terms. So this is what you have to do. Then add these terms together. So you add this with this, this with this, this with this, and this is your summation k running from 0 to 10. So this is so add these terms, right? So this is how you can obtain it graphically, very simply graphically you can do it. Now let me show the same thing to you if we perform this analytically. So what is our y of 0? Let me revisit that. So y of 0 is summation k running from 0 to n minus 1 x of minus k x2 of k. See, we can do this very simply if we follow this procedure. That we will do in the next session. But today I want to give you the feeling of what do we mean by circular convolution, how it is evaluated, means how this circular shift is evaluated here. And my aim is to show you that today. How do we evaluate this? What is going on actually here, right? So what we'll do, we'll obtain the expression now analytically. So this is the expression, expand this, means substituting the different values of k. This will be x1 of 0 and x2 of 0 plus x1 of minus 1 and x2 of 1, right, if it is 1, plus x1 of minus 2 and x2 of 2 plus so on, x1 of minus m, sorry, some last point is n minus 1, so the last point is n minus 1 and there is this n, then x2 of n minus 1. Right, so this is if we expand, these are the two different values of k, right? I know what is this x2 of 0, x2 of 1, x2 of 2, x2 of n minus 1. But what is this x1 of minus 1 modulo n? X1 of minus 2 modulo n. What is this? Now, how do we evaluate a modulo for a negative number? Remember, in general, if it is, this is very, very important. So let me use the red marker here. Let's see this. So in general, if we have any signal x of minus m of n, how do I write this? How do I write in this? What you do, you simply add n to it, means you add n to this argument, then this will give you, this is that sample actually. This means this is the sample x minus mth sample. Okay, so how do I obtain this if there is a negative term? If there is a negative term, and this is the literal meaning of modulo, and this comes from discrete mathematics actually. So that's not my topic here. How do you evaluate this? That's what I'm showing here. How do you evaluate this term? So if it is minus n, for example, minus 1 modulo n, you will write n minus 1. Right, that will do. That will give you the sample point, that sample value. All right. So let's go back and let me say y of 0. So substituting the value here. If there is 0, you don't need to do it because this modulo 0 means 0, right? It means 0. So you don't need to do anything with this. Now x1. Now there is a negative argument with this. So to make it positive, what we do, we add simply n. So it will be n minus 1 and x2 of 1. x1 of add n to it, and it will resolve the problem. So on x1 of n minus n plus 1, x2 of n minus 1. Now let me evaluate this term. So this will be x1 of 0, x2 of 0 plus x1 of n minus 1, x2 of 1 plus x1 of n minus 2, x2 of 2 plus so on x1 of 1, x2 of n minus 1. All right. So this is y of 0. So this is our y of 0. Have a look at this expression. Have a look at this expression. This one. And have a look at this expression that you obtain directly by using the graphical values. Have a look at these two expressions. Now compare these two terms. These are exactly one and the same. Right? Here you obtain the result by reading the terms in reverse order. Here you resorted to the modulo operation, extra modulo operation. All right. So to resolve the modulo operation means to make the argument of a negative number a positive, means to make a negative a positive in on this modulo sense. Then what we do, we simply add with the modulo, whatever modulo you are using here. Now we are doing modulo n. Modulo n means add simply n to that. That will make the argument positive. And you can see the result will be identical. All right. I hope you have got the idea. Now let me do y of 1 for you. So we know y of n is summation. This is a circular convolution formula again. I'm repeating that. It's 1 of n minus k modulo n x2 of k. x2 of k. So this is x2 of k. So how do I obtain y of 1? Put n equal to 1. So k equal to 0. N minus 1. x1 of 1 minus k and x2 of k. Right? Now, without first giving you the mathematical sense, how do we evaluate this circular operation? How do you obtain this circular operation? Let me repeat this by doing it graphically first of all. So this is the circle. I will arrange the terms, and I'm using them starting from this location. This is A, so I will arrange the terms first. So this will be x1 of 0, x1 of 1, x2 of x1 of 2, x1 of 3, and so on. Finally, x1 of n. So this is my last step. So I have arranged the terms in the counterclockwise direction. Now to obtain x of minus k form, first of all, I will read the terms in this clockwise fashion. And to get x of 1 minus k, what I will do, I will shift this. I will rotate the circle by 1, means 1 moment. Let me tell you what I am saying here. What I will do. So this is my A, where I started. What I will do, I will rotate this circle. Now what do you mean by rotate the circle? Every sample point will get rotated. So this is now x of 1 and minus 1. So when you rotate this, this comes here. And this will, x of 0 will move here. x1 of 0 will move here. This is x2 of 0. This is x, sorry, not x2. This is x1 of 0, x1 of 1. This is x1 of 2, and so on. The rest of the terms you know like this, and the last term one now will be x of n minus 2. So this will be our last term. That's meant by one rotation, and to read the values means to get x1 of 1 minus n from this, sorry, not from K, this is K, and this you can say this is letter, this sequence. How will you read? You will read the values in clockwise direction. Please remember that. So this is x1 minus 1, x1 of minus 2, so on, x1 of 2, x1 of 1, and x1. Have a look at this. That's what how I have it. So I have to always keep the track of this where is the starting point. Alright. Now what I have done to obtain this, my point is to obtain this graphically. Right now I'm doing it graphically. I'll show you how to do it analytically. But first, what I am doing, I'm giving a one rotation to this in the counterclockwise direction. In which fashion I have arranged the terms. But my aim is to read here x1 or minus k. But to read my x1 or minus k means I have to write the values in this fashion. So this means x1 of minus k is simply this. This will be x1 of, sorry, this will be x1 of 0, x1 of n minus 1, x1 of n minus 2, and so on. Finally, you have x1 of 1. I am reading the values. Now, to get x1 of 1 minus k modulo n, this is I give a one shift to this in the clockwise direction, in the counterclockwise direction, and this comes the first location, and this is in this location, and this is how we do it. Right now, what's the aim? Aim is to multiply this sequence that's here with this. So when you write x2 of k with it, you say this is x2 of 0, x2 of 1, x2 of 2, so on, x2 of n minus 1. This is our last sample one, and multiply the corresponding sample points. Right? Multiply the corresponding sample points. Then add them. Summation means add them. Now let me show you the same operation. I'm doing it analytically. So our y of 1 is simply summation k running from 0 to n minus 1, x1 of 1 minus k modulo n, x2 of k. In the next session, I will show you the very simple process of the evaluation. But this time, I want to give you a feel of how do you read the circular shift operation from this. That's the whole idea of doing this very tedious job. So let me first substitute the values of k. So it will be x1 of 1 minus 0. K is 0, so it will be 1 minus 0 of n, x2 of 0 plus x1 of 1 minus 1 is 0 modulo n, x2 of k plus x1 of 1 minus 2, that's minus 1 modulo n, x2 of 2 plus x2 of 1 minus 3, that's minus 2 modulo n, x2 of 3 plus so on. So last point will be x1 of 1 minus n minus 1 modulo n, and k is equal to n minus 1, x2 of n minus 1, right? And k becomes equal to. Now let me simplify this. So this is x1 of 1 modulo n, x2 of 0, x1 of 0 modulo n, x2 of, sorry, this is here in this one. This is 1. So this is 1 plus x1 of minus modulo n, and you are multiplying this with 2 of 2 plus x2 of minus 2 modulo n plus so on. Plus 1 of 1 minus what will we do? This will be this is so this is 2 minus n, I guess. I hope I'm right. And please pay attention and see whether I have done it right. So this is our y of 1. So this is our y of 1. Now remember, any positive number by modulo operation is the number itself. Now what I am saying, I mean this x1 of 1 modulo n minus x1. So you don't need to do anything with this. Again, with 0 modulo n minus 0 itself. Now, how do I evaluate this? I said the simple trick is add one n to it. So you are doing modulo n. So add n to it. This will be simply x2 of 2 and taken right. Then x2 of add n to it. This will be x of n minus 2, x of 2, 3 plus so on. And when you add this will be 2 minus n. When you add n to it, will be x of 2. Okay, I hope I'm right. Okay, can we? Right, please check this. So this when you add n to it, this will be a negative number. N is larger than this. So when you add n to it, it will be 2 minus 2 plus n. So n and n will cancel. It will be x of 2. So this is how we compare the circular convolution with the sequences. So this is how we compare the circular convolution. Alright, in the next session I will show you a very simple trick to evaluate this without resorting to this complicated modular operation. We'll do it very simply. Now please continue this procedure. Please continue this procedure after a while. That is the last thing. Check that result. Alright, check that result. Please do that yourself. Alright, so please do that yourself. In the next session, we'll do the examples for this circular convolution. And how we evaluate this graphical. That will be a very simple procedure. Right?